This is question number 3 on the 2023 exam. This is the 1D array question. So part A, we are starting with a weather data class. And inside there, we have an array list of doubles called temperatures. The first part is going to clean the data by removing the temperatures of all values that are less than the lower or greater than the upper. So that's what we need to do in part A. Public, void, clean data, double lower, double upper. So we're going to remove anything that's lower than the lower and or bigger than the upper. And since it's an array list, we can just use dot remove. So the first thing we're going to do is write our method header, which is public void, which means we're not having a return type. Clean data, double lower, double upper, and they gave us a picture that we can look at on the second part of the problem or on the next page. So we can look over here. So we're going to traverse our array list of temperatures. So for int I equal to 0, I less than temperatures, dot size, I plus plus. Remember that array lists are constantly changing, so you need a method for the size. Also, array list only takes objects, so that's why we have up here with the array list, we have the double that is auto boxed. So it automatically takes a double as a primitive and wraps it up and treats it like an object. The computer does the unboxing and wrapping all by itself. You don't need to worry about that. So we're going to look for our temp at each piece. So double temp is going to be the array list with its temperature. Dot get I. Temperature, sorry. This is going to temporarily store it just so that we don't have to write as much on the next line. So now we're going to check if we have to remove the temperature. So if the temperature is strictly less than lower, or if the temperature is greater than upper, then we're going to remove it. So we're going to do temperatures dot remove I. This doesn't have a return type, so there's nothing else we need to do. Our first point comes from traversing the array with no error bounds. Next one is checking the thresholds to make sure you're above the upper or below the lower. We remove what we need. And lastly, we remove everything correctly. So the first part is worth 4 points. Part C, they called this method with 85.0 and 120. Notice this is bigger than 120 and it is now removed. This is lower than 85, so it is next going to be removed. And again, this is above 120, so it is going to be removed. Everything else remains in the same order. Part B. Again, our says we're going to write the longest heat wave method. So we're going to try and find the longest heat wave. And what they want is the longest heat wave over a certain amount. So right here, we're asking for how many days are we over 100.5. So right here, we are over 105 for 2 days. So that would be the length of that heat wave. But over here, we also have another one with length 3. So that would be the longest heat wave. So we're going to have to keep track of 2 different variables. One for the current length and one for the max length. I'm going to write this as an enhanced for loop because we don't do enhanced for loops as much. So public int longest heat wave. How was this scored this year? First point is going to come from traverse. It's not a parenthesis there, I'm sorry. And we have to pass in the threshold that we're concerned with. So at first, we're going to take our current length and set it equal to 0. And we're also going to do our max length and set it equal to 0. So now we're going to traverse our temperatures array. So remember with the enhanced for loop, we put the data type, a temporary name inside the name of the array. So if our current temperature is bigger than the threshold, then our current length is going to increase. And that is all one word, current length, that's my variable. Now, if our current length is bigger than our max length, then we found a new max length. This is all in one big thing right here. If that's not true, if our temperature is not bigger than our threshold, then our wavelength, our current wavelength gets set to 0. And finally, at the very end, we're going to return our max wavelength. So max length. With no air bounds, we compare to threshold. We increment the current length as needed. We look for the longest one, and we return the appropriate value.